G'day, welcome to this ADF Mobile Insider presentation. My name is Chris Muir, I'm an ADF Product Manager for Oracle Corporation. Now let's imagine this scenario. You work at a large oil refinery and your job is to go and inspect the thousands of kilometres of piping for problems. And while you're walking around on your daily inspection, you discover some of the piping has rust in it. Now you need to lodge an incident report. So what would you rather do? Would you rather, for the incident report, get out your pad, scribble down some instructions of how to find that piping, go back to your office and report by entering an incident report into your computer system of where that actual incident or that rusting piping is? Or, while you're out on site looking at the actual piping, would you like to rip out your tablet, take a photo of the actual piping, use the GPS on your tablet to actually locate where the rusting piping is, fill out the incident report there and then in your tablet and sync it back with the main headquarters computers? You're going to be able to provide a lot more accurate information, and your productivity is going to be massively boosted because you're not going to be going backwards and forwards to the office to enter this information. You can do it all on site and it'll ultimately be a much more productive experience. The ability to not only merge enterprise business functions of data entry on our smartphones and tablets, as well as using all the facilities of our smart devices such as the GPS, really has the opportunity to provide a large benefit for enterprises. With the benefits of all your workforce having GPSs and all the other services available to them on their smartphones and tablets virtually in their pockets, it's a fantastic opportunity for you to make use of these. So what I'd like to do in this ADF Mobile presentation today is specifically talk about the GPS services and how you can integrate these into your ADF Mobile applications to ensure the success of your mobile application development. As such, what we'll cover in this in-depth presentation today is the three different ways you can use your mobile device's GPS or geolocation services, that being through the data control palette, the Java APIs, or the JavaScript APIs. In addition, we'll discuss some extensions to both the Android emulator and iOS simulator to make testing the GPS services easier. Before we undertake this deep dive into the GPS services, I need to highlight the fact that this presentation was published with ADF Mobile version 1. Specifically, this was for JDeveloper release 11.1230. By the time you view this presentation, there may be later releases of ADF Mobile that might have resulted in changes to some of the content that I'm going to discuss today, in particular the APIs. Please take time to consult the latest ADF Mobile documentation via this bit.ly link to ensure that you have the latest information at hand. So returning to the content, first let's cover off the overall architecture picture of how ADF Mobile integrates with the device services such as email, SMS, the camera and the GPS that we're interested in today. This picture shows you the common architecture diagram for ADF Mobile, and specifically in red the overall JVM container that ADF Mobile runs in on your iOS or Android device. In order for the ADF Mobile application to connect and communicate with the device services, ADF Mobile makes use of PhoneGap, highlighted here in blue, which provides these services. PhoneGap, also known as Apache Cordova, provides the APIs under the covers that ADF Mobile makes use of to access your phone or tablet's email, SMS, camera, GPS and contact services. It's worthwhile noting, though, ADF Mobile abstracts away from the underlying PhoneGap solution and wraps ADF APIs around those PhoneGap services, though underneath it is indeed PhoneGap that is used. As such, not only is Oracle documentation a valid place to look up information on how to use these services, so is the PhoneGap or Cordova documentation. In particular, this external documentation includes useful information on the capabilities and limitations of the device's services you're likely to deploy to. Overall, ADF Mobile through PhoneGap provides a wide range of services you can make use of on your phone or tablet, such as the geolocation services we're going to discuss today. In addition, ADF Mobile provides multiple different mechanisms for developers to make use of those facilities, some of which are available for all services, some are limited to particular mechanisms only. Of those mechanisms, there's essentially four. The first is the data control palette, which is one of the main productivity boosters of the JDeveloper IDE. Through a device data control and associated methods, this allows developers to literally drag and drop the associated device services, such as GPS, onto an ADF Mobile AMX page, and JDeveloper will wire up the page and components such that there is little programming required on the developer's part. The second mechanism is EL, or expression language. Through EL, an explicit device scope object is available to allow developers to query the device surfaces. For example, the GPS service, if you're going to include that facility in an AMX page through a button, it might be useful to actually test, does this actual device have the geolocation services available? Through the EL expression hash squiggly brackets, device scope.device has geolocation. So this function returns true or false, and through this you can actually enable or disable the GPS button in your application. Alternatively to these mechanisms, if the developer wants more control over the service integration via a Java managed bean in their AMX pages, there is also a Java API that provides programmatic access to these services. As you can see in this brief example, the Device Manager singleton accessed via the Device Manager factory provides a method called start updating position that allows you to periodically, in this case every 20,000 milliseconds, to periodically get the location of the device. Finally, if you decide to create local HTML pages in your ADF mobile application over AMX pages, there is also a JavaScript API available to you to get the current location. With all of that in mind, let me now demonstrate how to build an ADF mobile application that integrates the GPS through the data control palette in an AMX page. Okay, what you can see here is JDeveloper 11.1.2.3.0, where I've already created an application workspace, an ADF mobile application workspace called GPS Demo. Within the GPS Demo ADF mobile workspace, in the features file, I've already created a feature called GPS feature, which is of type AMX, and the AMX page itself is called Start Location Monitor.amx, which you can see here. The Start Location Monitor page at the moment is a very basic page. It includes a panel page, a header facet, and an output text that says header, and you can see the result on the right hand side. Now for this particular presentation, what I'd like to do is introduce the GPS features, and what we're going to use is the data control palette to drag in the GPS features to start out with. And you can see the data control palette down here on the left hand side, and a data control called device features, which has a number of method calls available to us. The one we're specifically interested in initially is Start Location Monitor, and you can see that it takes a number of parameters, and we can see this by expanding the nodes, and there are the 3 parameters there. Now the 3 parameters are interesting. The Enable High Accuracy parameter, a Boolean parameter with values true and false, what this enables you to do on the device is obviously improve the accuracy of the readings taken from the GPS on the device. Now the documentation between Android and iOS is a little bit shifty on this, but basically what it attempts to say is if you put this to false, typically what the devices will attempt to do is locate themselves according to the Wi-Fi signals around them. However, if you set this to true, as long as the device actually has a GPS inside it, and not all devices do, some iPads don't, for example, then if they do, then it will actually attempt to use satellite GPS services. Now the difference between both of these is the satellite services will give you a far higher or accurate actual location, whereas the Wi-Fi solutions, well, it's a generalization based on the Wi-Fi signals around you. So if you need very detailed or very specific locality information, then you need to make sure that the devices that you're using do have an actual GPS device in them and are not just relying on the Wi-Fi signal. The update interval section, or parameter I should say, gives you an idea about what this method's actually doing. Start Location Monitor actually turns on a monitor that's going to periodically, that is based on the update interval parameter, which is a milliseconds parameter, it will effectively every time that hits that interval it will get a location from the GPS services. So you can set this to 2,000 milliseconds or 50,000 milliseconds or something a lot longer than that to actually read from the GPS and get the current location. Talking about the location, the third parameter, location listener, is possibly a little tricky and makes the GPS data control a little bit more difficult than integrates so many other device services. because what that has to be is a managed bean based on a method called location handler that takes a parameter called location, which returns the current location every time the GPS is read based on the update interval. So don't worry, I'm going to show you how that all hangs together. So I'm going to drag in the start location monitor onto our page, and as you can see, JDeveloper IDE allows us to either drop in a parameter form where the user will have a number of input text controls to enter that data themselves. Now for the GPS that doesn't really make sense. So alternatively what we're going to do is we're going to drag in the start location monitor. Oops, I'll just do that again. We're going to drop them in as a button, and this time we're going to programmatically provide the values for that parameters. So what we're going to do is enable high accuracy to be false. We're going to enable the update interval to be 2000 milliseconds, and this is the location listener. Now the location listener is a bit of an odd parameter in terms of ADF programming, because typically these parameters would either take a literal or they'd take a value, an EL expression like this. So in this case we actually have to name a specific bean and its function that will provide the location listener. So we're going to back out of this dialog. We're now going to create a managed bean. Now I've actually already cheated. I've already created a managed bean called GPS, but I haven't yet configured it in the ADFC mobile config file. So I'll go into the ADFC mobile config file. I'm going to just configure that bean very quickly. So in my EL expressions I refer to it as GPS. I then need to wire in the specific class, and it's going to be available in view scope. If we have a look at that GPS class, you'll notice that it has a very specific method in it called location handler, and it takes, or I should say it gets passed, a location which is actually the current location when the GPS is doing its poll. Now that current location object returns us all sorts of different values about the user's or the device's current location, including the accuracy of the location taken, the altitude, latitude, longitude, the heading, speed, timestamp, when it was taken, and in addition the watch ID. And we'll learn more about the watch ID a little bit later on. Now in order to demonstrate this to you when we actually get up to running this in the simulator, I'm actually going to log the output of the current location to the logger, and you can see that effectively I'm going to use the application logger utility. I'm going to log for severe level, I'm logging for this particular class, the actual log message header is going to be location handler, and then we're just going to output the timestamp and the latitude and longitude. So at this point we've now wired up our managed bean, okay, GPS, which has the location handler in it. So returning to our page, if we go back now to the data control palette, drag in the start location monitor, go to the method and add it as a mobile button. We set the enable high accuracy to false, the update interval to 2000, and watch what I do here. Notice how in this particular field, for this particular parameter, I do not enter an EL expression. What I actually do is just refer straight to the specific piece of code here in my bean. I still have to put the scope, I still have to put the managed bean name as opposed to the class name, and I'm also referring to the location handler method. That has to match that, okay? Otherwise this won't work. But in the end, okay, we've basically got it wired up there. So as a result, we can see in our AMX page we now have a command button, okay, which has the text start location monitor, which we can see in the little preview on the right hand side, and we can notice in the action listener that it's calling a bindings.startLocationMonitor.execute. What's that? Well, in this particular AMX page, if we switch to the bindings, we can see it has a page.def file, and here we can see the binding start location monitor, and if we click on the edit button we see the same dialog we had when we were dropping the actual start location monitor method onto the AMX page. So now, by the magic of me recording this video, I've already actually deployed this application to the iOS simulator. So I'll come over here to the iOS simulator that's running in the background, and you can see the GPS demo. I'm going to open it, and you can see the page with the start location monitor button on it. Now, the thing about the iOS simulator is how does it actually simulate locations or the GPS? Because my actual computer that the iOS simulator has does not have a GPS embedded within it. If you notice the iOS simulator menu up the top, when we go to the debug menu, you will notice that we've got a menu option called location, and this actually allows us to simulate GPS locations. Now I happen to have already pre-configured a location in this actual iOS simulator to this lat and long. So this is how we would effectively set up different test values for our GPS application. So now, if I return to the iOS simulator and click on my Start Location Monitor button, the first thing we'll get is, well, typically in iOS, it will always warn you for the first time you ever run the GPS services. If the application is trying to access the GPS, it'll actually ask the user, well, do you really want to do that? And we're going to click OK. Okay. So you can see the little location button in the, location icon in the top of the iOS simulator. And if we go to the console, at least in the iOS simulator, you'll notice now that there is a number of different logs being written. Now, why is it continuously writing more logs for the GPS demo? Because the Start Location Monitor, remember, it has a parameter that essentially says update interval. So every 2,000 seconds it's going off now and checking the GPS location. Now, if you remember in our GPS bean, we have a logging method. And if we return to the console, we have a look at this particular item here, the severe item. You can see that the severe message, so just again to remind you, I was logging at severe level. The severe message is pumping out a message which has a timestamp, a lat, and a longitude value. So we can see that that's pretty much constant at this stage. Given we now looked at the data control for wiring up the GPS within our ADF Mobile applications, what we'll now look at is instead using the APIs, the Java APIs, in fact, to access the GPS, which will give you a bit more programmatic control over actually the calls to the actual GPS services. Returning to JDeveloper 11.1.2.3.0, you'll notice in the feature file I've created a new feature called GPS Feature by Java. And if we have a look at the content of that, again, it's just a simple AMX page called GPS by Java. If we have a look at that page, GPS by Java, at the moment it doesn't include anything, and we can see that represented in the preview on the right hand side. But what we want to do here is include a button that when we click on it calls a manage bean method to actually call the GPS services at the Java API level. So I'm going to drag in a button from the component palette, we'll change its label, and from here we'll click on go to the property inspector and click on the behavior node, and you can see that we've got different behavior properties such as action listener. If I click on this little ellipses, edit, we can now actually configure that particular property to call my manage bean. Now the reason this is here is I've already set that particular class up previously, GPS, as a manage bean in the previous demo, so it already knows about it here. And I'm going to create a new method called doGPS. So you can see we have a text button called GPS with an action listener that calls viewscope.gps.doGPS. And if we go to the GPS class, which is already open here, you'll notice we have a new method called doGPS, which takes an action event as a parameter. So here we have one of the Java APIs that are available to you for working with the GPS. Essentially, all device services at the Java API level are provided through a singleton called oracle.adf.model.datacontrollers.device.device.manager. And we can see in this API example that there is a method called start updating positions on line 15, 16, and 17. And this is really the equivalent of start location monitor from the data control palette. As you can see on line 16, it has very similar parameters of update interval and enable high accuracy, and there really is no difference here. The additional parameter of the watch ID, well, this is really just an abstract name for the actual GPS location service when you start it. So later on when you want to stop it, you can use the same watch ID to tell the underlying services that you no longer want to use that GPS services. In fact, if you look at the signature of this method on line 15, public Java lang string, so it returns a string, what it does return is the watch ID. Finally, on line 17, you can see the geolocation callback. Now this is very much the same as the location handler that we saw a little earlier on. So with that in mind, let's have a look at an example. So here we have an actual example that shows the start updating position method called. What you can see on line 4 is our do GPS method that we configured in our GPS bean, our managed bean earlier on. And on line 5 you can see that we get a handle onto the device manager object by calling device manager factory.getDeviceManager. On line 7 we then call start updating position, and you can see it as part of the first parameter for this guy. It's the updating interval in milliseconds, or ultimately 20 seconds here. On line 8, true is the GPS accuracy, so in this case we'll be attempting to use satellite services. Also on line 8 as the third parameter you can see the watch ID, so literally we specify this into the method, it's passed in and it's passed out back on line 7 as the actual watch ID. The fourth parameter on lines 9 to 11 is an anonymous class, a geolocation callback, which is an abstract class which requires a method called location updated. So when you pass this in as a parameter on the actual GPS services being called every 20 seconds, this method will be called on your behalf. And within that you can put your own code, as you can see here on line 11, to do whatever you need to do. Maybe update some bean values, maybe update values on the screen. It's totally configurable, up to you to decide. Just returning back to line 7, again remember the watch ID, and this is very important, because on line 14, at some point we'll want to stop the GPS service from polling the actual GPS device services on the device. And to do that you call device.clearWatchPosition and you pass in the watch ID. So now you start to get an idea why the watch ID is so important. The alternative method which is available to you via the Device Manager class for getting the position is in fact called getCurrentPosition, and as you can see on lines 10 and 11 it has two parameters. Now enable high accuracy is already familiar to us, but what is the maximum age? What the maximum age says is if last time the GPS actually got the position that's within the maximum age that you supply, then it will use that value. But if the last time the GPS was actually called is longer than the maximum age in milliseconds, then it will actually use the GPS services on the device once to actually get an updated value. So in a way the maximum age allows you to use the cached last position if it's within a certain time period, but otherwise it will go off and update that for you once. You'll notice the getCurrentPosition method returns a location, and that's very much the same as the location handler parameter that we saw earlier on. If we look at an example, again based on our managed bean GPS with the do GPS method, we can see on line 5 we get a handle and a device manager. Then on line 7 we can see a call to getCurrentPosition with a maximum age of 60 seconds and the high enabled accuracy. That returns on line 7 on the left hand side of the expression a location object which we're referring to as position, and it provides a number of methods just like we saw in the earlier data control Java bean example to get the latitude, longitude, accuracy, height and so on and so forth. From the context of the Java APIs there are some extensions that you may wish to include. The device manager object includes methods like hasGeolocation, which returns a true or a false, and you can use that as a programmatic check before you call these other methods to ensure that the device actually has GPS services on it. Now my understanding is most iOS devices do, but some Android devices don't, so you can see the need for maybe a method like this. Another thing that you can do from a defensive programming point of view is check for the exceptions, and in this specific example oracle.adfmf.framework.exception.adf exception, and this is the generic exception that the ADF Mobile framework will throw. So for instance, if the user has turned off the geolocation services for that particular application, they've stopped that application actually accessing those services via the settings on the device, well, an exception will be raised and you may need to handle that. So you can wrap this exception in a try-catch block to attempt to control the actual, well, I guess from a user-friendly perspective, control the error messages that are displayed to the user. For the final demonstration of this particular presentation, what I'd like to look at now is showing you how to call the JavaScript APIs from a local HTML page rather than an AMX page. That is a local HTML page to access the geolocation services. So again we return to JDeveloper 11.1.2.3.0, and again in the GPS demo ADF Mobile workspace within the feature file I've created a new feature this time called GPS feature by JavaScript. And what's a little bit different about this guy is he is not an AMX page. He's in fact using a local HTML page that will be deployed to a device called GPS by JavaScript.html. Okay, the file is already open and there's really nothing to it at the moment. Before we have a look at an example of calling the JavaScript API, it's worth mentioning the fact that with the JavaScript APIs, what we're actually doing is calling the PhoneGap or Cordova JavaScript APIs directly. So with the Java APIs, they're really wrappers that Oracle's written around the PhoneGap APIs, but in the case of HTML, you're just making use of the PhoneGap APIs. Now, what this page is trying to allude to then is if you're making use of the PhoneGap or the Cordova JavaScript APIs, then a really good reference or documentation for them is the documentation of PhoneGap and Cordova itself. And as we can see via this 1.0 version here, so this is the current version of ADF Mobile, version 1 uses the 1.0.0 Cordova JavaScript APIs. Well, they have full complete documentation to use, geolocation services documented, and the method that we're just about to have a look at, an example, is the getCurrentPosition method, and there's plenty of information here for you to read. Now, why I really like this and I wanted to refer you to it is that these Cordova documentation pages have a lot of really excellent documentation around the quirks of actually making use of these services on different devices, that being iOS and Android and so on and so forth. And when you work with mobile development, it's these little quirks that will actually make your development tricky. So the better or the more improved documentation you have about all these quirks and how to code around them is a particularly useful thing. So check these pages out. Anyway, returning to an actual JavaScript example, in this example you can see straight away on lines 4 to 6 we actually import the PhoneGap JavaScript library as well as the ADF EL JavaScript library, which we'll embed in our local HTML page. Then right down on line 22 within the main body of our HTML page we have a button with the label getPosition that calls a JavaScript function that we've defined called getPositionInTerm, which starts on line 8. Now that function on line 8 calls the PhoneGap object navigator.geolocation.getCurrentPosition function, which essentially takes two parameters, functions in their own right, called onSuccess and onError. Now the onSuccess function, as you can see in this sample, if the getCurrentPosition method actually succeeds, the onSuccess function will be called, the current position will be passed in this case it's referred to as pos, and then you can do whatever you want with that position. As an example on line 13, I've gone pos.chords.latitude and pos.chords.longitude. I've actually retrieved those to retrieve the lat and long and display it via an alert to the user. Alternatively, if the getCurrentPosition method fails, the function onError will be called, the error object will be passed into it where you can do any exception handling that you need to do. So returning to JDeveloper, you can see I've copy and pasted that JavaScript example in. And by the magic of video recording, I've already deployed this to the iOS simulator. So let's have a look. You can see my HTML JavaScript feature, my big HTML page with a big fat getPosition button. And if I click on that, you can see the JavaScript alert that returns the lat and the long. Just to remind you, where did that lat and long come from? Well, if we click on the iOS simulator debug menu, location menu, custom location, you can see the custom location of the lat and long that I entered earlier, and that matches what we're seeing in the JavaScript alert. So in the final part of this presentation, let's just talk about testing the GPS with the iOS simulator and the Android emulator. Now, from the iOS simulator point of view, we already saw the debug menu location option, the custom location option for entering your own custom latitude and longitude value. And that's great for testing just a single location for your application. What happens if you're building an application that requires the user or the device to move around? So like a driving application or an application, maybe if we take our oil refinery example, where you're walking up and down the length of the oil pipe and you want to get a number of GPS locations. How do you test that? That's where the other options under that debug locations menu come into play, such as the Apple Store, the city bicycle ride, the city run, and the freeway drive options. And what these all do is in the simulator is essentially these all simulate a user moving around Cupertino, Apple's HQ, around Cupertino, either driving or walking, either fast or slow, but essentially every few seconds, I'm not actually sure what the period is, but it will update and change the location. So then you can use that with our Start Location Monitor API to start tracking over a number of periods where the user is actually moving to. For the Android emulator, it's a little bit different. What you don't have is necessarily the same facilities there. Instead, what you do is you start the Android emulator, and then in a terminal or command line window, you then telnet into the Android emulator. And once you do that on port 5554, you then issue a command geofix, so geo space fix space, and then your latitude and longitude values with spaces between them. So in this way you have to programmatically influence the Android emulator, but you could write a little script that periodically sleeps and then logs in, and or I should say telnets in and changes the latitude and longitude to simulate very much what the iOS simulator does in turn. So that concludes this presentation on integrating the GPS into ADF Mobile. Now, a couple of summary points just very quickly to emphasize for you. Remember that all the device features in ADF Mobile are ultimately accessed through the PhoneGap and Cordova APIs. So while referencing our documentation is a good start, if you want to understand all the little quirks of accessing the device features, things that run differently on Android and iOS, that third-party documentation is a good source of information. As we also learned, there are multiple different ways within ADF Mobile to access these device features. If you're using AMX pages, the data control is a very good way to start programming with these device features because it wires up the pages for you. But if you want more programmatic control from your AMX pages, then with a managed bean you can call out Java APIs, or alternatively with local HTML you can use the JavaScript APIs, which are the PhoneGap APIs in this case. As we concluded in the presentation, we see that testing via the iOS simulator and Android emulator, while there are features in there for allowing us to replicate latitude and longitudes, well, where the device is located on a latitude and longitude and moving lats and longs, in reality you really need to test on the actual devices. If you read anything about mobile development, they always tell you the simulators and emulators are good, but you have to get out there and test with a real device, so keep that in mind.